Here, I really can't see it very well, so. Mhm. Okay. Well, we're zipped right on through these, and we've got so many other things to talk about that you can't believe it. One of the things which we're going to be seeing is this device. And it's a 1/4 size version of the one that we've just been looking at. It's built in this suitcase. It actually only takes up the top half of it. The suitcase is mostly empty. Well, that gives you some idea of the size. It was just a little bit too long to put into an ordinary briefcase, and that's why I went to the suitcase. But the suitcase has wheels on it and rolls and has a handle that pops out, and that makes it real easy for me to carry with me when I go overseas and other places with this. Here you can see the handle. I guess, well, maybe you can. No. Okay, well, we're going on to something else. We have so many things to look at that you can't believe. Okay. Okay, there's it is standing up in the den at home. And I have 4 of these fans that I normally use, but due to space limitations, I only brought one. Okay, there's... okay, it's too dark. It's too dark. Okay, let's see something else. These are some of the tools sitting beside the large capacitors that we were talking about a while ago that came from Finland. Yes, sir.
What does that suitcase do?
What does what do?
What does the suitcase do?
This particular one, how much output?
No, how much output?
Oh, those instruments?
No, don't. The suitcase. What's that? The suitcase.
Okay, we're going to take the suitcase and play with it in a little bit. It has a complete unit in it that's fully functional and does everything that anyone would imagine. Basically what I've done is reduced it to an off and on switch, which is the level which seems most people seem to be interested in. So I'm going to accommodate those fellows in a little bit, and we're going to run some tests on it to see for sure that it's doing what I'm saying it's capable of. Okay, here's that radio frequency high voltage meter that the probe that we saw earlier was hooked onto, and those are Hewlett-Packard instruments that we're seeing. There's more of them. So this is just for you fellows that are thinking that somebody fell out of a tree sort of thing. And I might mention that you see the high voltage probe with it for high frequency high voltage probe, and then here's some of the other instruments. They're common. That center one, it goes to 600 amps plus or minus. So there's a 1200 amp spread on it. Yes?
Do you have a schematic?
The schematic of this, at this point, I'm going to be talking about this up to a certain point, and then I'm going to, there's going to be a wall put up, and that's about as far as I'll go, because this thing is highly commercial. It's in more than half the world right now. It's being manufactured, and the monetary interest which I have in it is substantial, and it's not to my advantage to be overly talkative. I'll try to be direct, straight, and so that you know that it's really happening, and if you're real sharp, you can probably figure the parts that I'm not telling you out. So that's to eliminate the competition, which basically probably doesn't, I don't need to worry about that because the backing which I have is of such a nature that there's nobody in the world that can compete with me anyhow. So it would be foolish for anyone, regardless of how big they think they are, to even try. Okay, most of you probably got your Tesla magazine this year, and the current issue, and on page, starting on page 33, there's what was 26 pages printed by a laser printer has been reduced down to about 5 pages, and it has a lot of update information which will tell you why these things will work and why it basically blows the conventional approach to electricity out the window completely and forever, and in a way which it could never get back in, because if you read the article, you will never be able to go back to where you were before. So if that makes you uncomfortable, you don't want to read it. Okay, we're going into some of the other background that led into this thing. Okay, there are a number of publications in Europe which, in Europe, they don't take such a dim view of what I'm trying to do. Okay, those of you that can read French, I'll move this up a little bit, and we're going to skip through a book that was published quite some time ago, and we're going to show you some devices which have predominantly amperage and not necessarily voltage, and they look a lot like the Tesla coils which you're accustomed to see. There's a reason for that, and we'll go into it in a little while. But this particular fellow, D'Arsonville, was the one that gave us the thing for looking at heartbeats and your cardiograms, and gave a lot of thermo devices which kill germs. They were using the thermal effect of high voltage electricity to kill germs back in the late 1800s. Instead of, they didn't have disinfectants and things at that time, but they were very successful with it. So some of the illustrations from this particular book I'm going to show you, and then we'll skip on to get back to English. The particular book I'm talking about, there's 3 copies in the United States, and okay, that may look somewhat familiar, but if you know the year that it was built before Tesla was actually building coils, and it has a huge amount of amperage. And it has the center tap, like I'm telling you about on my coil system, which makes it into an amperage, voltage and amperage type device. And they had a great deal of difficulty with the amperage because they were all the time getting